Hello. In this video, I will do a short review on integration techniques. So we'll solve one problem with substitution and then a couple of problems with integration by part and two problems with trig substitutions. Okay, so here's the first problem. Let's find the definite integral. Integral of x squared plus 1 over 9 minus x in here to 8 I think dx. Okay, so you can see actually in this integral you have x squared and 9 minus x, given that 9 minus x to 8 in the denominator, but that's okay. We can convert this into power form. So first I split this integral into two integrals, because x squared in here and then plus y like dx over 9 minus x to the 8. Okay, so how to do with 1 over 9 to x minus x to the 8. So I will convert that like 9 minus x to negative 8. Okay, for the first integral, that is easy. It's just x cubed over 3. This is the power rule. Let me write out the power rule in here. Okay, so x to the n dx, that is equal to x to n plus 1 over n plus 1 plus c for the case when n is not negative 1. When n is negative 1, so you have another form that is ln of absolute of x. Okay, so for this integral, that is equal to integral of 9 minus x to negative 8 dx. You can do substitution, but if you can see that, you can write the answer right away, right? But for sake of convenience, I will use substitution. I will put u equal to 9 minus x, and then I have du is negative dx. From here, I can rewrite the second integral as 9 minus x, okay, negative 8 dx is equal to 9 minus x, that is u, so I write u to negative 8. Dx is just du, that comes from here, okay, so I write negative du in here. Okay, so basically that is equal to minus u to negative 8 du. So again, we use the power rule for this. I get negative u to negative 8 plus 1 over negative 8 plus 1 plus c. And then I have to plug the substitution back here. So my substitution in here, right? I have to plug this back here. So I get that is negative 9 minus x to negative 7 over negative 7 plus c. And the last step is, compile everything together, this and this. I will get the final answer. So the final answer is equal to x cubed over 3. Here, negative with negative will be plus, right? Plus. I can write 1 over 7, 9 minus x to 7. I just, here we have negative 7, so we write, just flip that and then plus c. That is, the first problem. Again, right, if you can see, like, from here, you can see, you can write integral of 9 minus x to negative 8 d to 9 minus x, right? And then with the negative in here, so you can write the answer right away. That is just negative 9 minus x to negative 7 over negative 7 plus c. So you don't have to do substitution. But anyway, either are good. Okay, now let's do some problem when we need to use integration by part. Okay, this is the second one. Integration by part. So let me remind you the general formula. So we have u dv equal to uv minus v du. And you know, this formula comes from the product rule. The product rule. Integration using substitution is some kind of, you know, reverse process of the chain rule, and here the product rule. All right, let's consider the following example. We need to find the indefinite integral antiderivative of x e to 2x dx, right? For this combination, you know, I will write general form of this combination, x to the m e to nx dx, right? So for such combination, you always put u equal to x to m, right? And then dv equal to e to nx dx. So I put u equal to x in this case, and then dv equal to e to 2x dx. From here, I need to differentiate fi du, that is just dx, right? And then v is integral of e to 2x dx. So I will not do substitution in here. Usually you can do substitution, you put u equal to 2x, right? But let's write the answer right away. So that is 1/2 e to 2x. Okay, so you have to check that for yourself. And now, in order to get, you know, the formula right here, in order to apply that formula, I will do the following one. I will take the first one in here and then multiply with this guy, right? And then I subtract, you know, minusing in the formula. So I subtract this guy, you know, usually this guy, and then I subtract this guy, you know, multiply with this guy under the integral. So I have the integral x e to 2x dx is equal to 1/2 x e to 2x, you know, x with 1/2 e to 2x, it's just this. And then minus, I can write in here, you know, 1/2 e to 2x dx, right? But since 1/2 is constant, we can take this out. We have this is equal to 1/2 x e to 2x minus 1/2, then e to 2x dx. You know, we just saw this, you know, integral previously. This right here. You can see it's right here. So basically, you only need to copy the result from the previous step. So you get 1/2 x e to 2x minus 1/2, and antiderivative of this is 1/2 e to 2x plus c. So you simplify that, you get 1/2 x e to 2x minus 1/4 e to 2x plus c. And that is the very simple example. So how to do integration by part. Okay, so let's consider another one, which is also a standard, a typical, you know, with integration by part. The second example in this topic is find antiderivative of x sine of, let's say, 2x dx, right? This is also standard combination, you know. Here you have x to m and sine of nx dx. So for such integral, you only need to put u equal to x to the m, and then here is dv. Okay, I didn't explain why we need to put u equal to x to the m, you know, because when we apply integration by part, we have to differentiate x to the m, right? So if in the previous example we have only one x, you see, we have only one x in here, and then when we differentiate, we already got, you know, 1, so you know x disappear in the second integral right here. If you have, suppose you have kind of, you know, x squared in here, right? So you need to differentiate twice, means you have to apply integration by part twice. All right, so in this situation we have x only, so let's put u equal to x, and then dv equal to sine of 2x dx, right? So you have to find du, that is just dx, you see, well, you differentiate one time and then you have dx, and x will disappear in the next integral. And v, that is antiderivative of sine of 2x dx. So what's that? That is, I write in short, 1/2 with the negative, and here you have cosine of 2x. All right, and now I will apply the formula of integration by part. Our original integral, I write here, integral x sine of 2x dx equal to, first, equal to x in here, multiply with this guy, okay, and then subtract this guy multiply with this guy. So this is equal to x with negative 1/2, so I write negative x over 2 cosine of 2x, okay, and then minus with negative in here, so I write plus, okay, I write plus in here, plus 1/2 integral cosine of 2x dx. And you can find this integral easily. That is, let me rewrite this, x over 2 cosine of 2x, and then plus 1 over 2. Again, we need 1 over 2 in here because the angle here is 2x. Remember that. You can do substitution, right, as you want. But I will write the answer right away. That is just 1/2 sine of 2x plus c. So overall, I have negative x over 2 cosine of 2x plus 1/4 sine of 2x plus c. So I think this is very standard. I hope that you can solve such similar problem if you have power 2 in here, right? You know that we have to apply integration by part twice. Okay, so I think 2 problems with integration by part, this is enough. Now I would like to show you how to do trig substitution. Okay, we have standard, 2 standard form in here. The first kind of problem is integral of sine to m, let's say just x, right, and cosine to n x dx. Another one is integral of tangent mx and then sequence nx dx. The reason we have such combination is, we have this x squared plus sine squared. Sine squared plus cosine squared is 1, right? And, derivative of sine is what? Is cosine, right? At the same time, derivative of cosine is negative sine. So what does it mean? That means, you can, when you do substitution, u equal to sine. So you differentiate that, you get cosine dx. So means you can change from sine to cosine, right? Very similar situation for tangent and sequence. So we have this identity, tangent square x plus 1 equal to secant square x, right? And we also have, what is tangent derivative? Tangent derivative is secant square. What is secant derivative? Secant derivative is secant tangent, or you write tangent sequence. All right, so we can use those relationship between sine and cosine and between tangent and sequence to solve such integral. All right, let's consider the following example 4. So we need to evaluate integral cosine 13 of x times sine of x dx. In this situation, both m and n are odd, right? So I can write here, yeah, m is equal to 13 and n is equal to 1. So in such situation, you have to choose the guy with the higher power degree in here, right? The guy with higher degree in here. So that is cosine. So you have to choose that and do substitution with this guy. Okay. So I will put u equal to cosine of x. From here, I have to find du right away. That is negative sine x dx. And after substitution, I have to rewrite the original integral in terms of new variable, right? So our integral, let's say that is I. So the integral I is equal to integral of cosine is just u 13, right? And sine x dx, where's sine x dx? Sine x dx is right here. That is just negative du, right? So I write negative du. So basically that is negative u 13 du. And you use the power form of integrals. You have negative u to 13 plus 1 over 13 plus 1 plus c. And you have to plug your substitution into this to get the final answer. So you have negative 1 over 14 and cosine of x to 14 plus c. You know, this is pretty easy, right? When you have odd and odd powers. Okay, let's move to another problem with tangent and sequence. Example 5. Let's evaluate this integral. Integral of sequence 28 5x times tangent 5x dx. So what is your choice? You know, in this situation, okay, let's do a short, you know, analyze, okay? So when you see something like that, you might try, you put u equal to sequence of 5x. Or you may try u equal to sequence, tangent, tangent of 5x. So if you do this substitution, let me show you, right? From here you get du is equal to sequence of 5x tangent 5x times 5 dx, because 5 is from the derivative of 5x. We need to use the chain rule, okay? So for this guy, you have, you know, du is sequence square x dx. Okay, now let's look at the original integral right here. So for the first choice, right, if you put u equal to sequence 5x, you get du sequence 5x tangent 5x. It seems to be good, right? It seems to be good. Why? Because what is sequence 8 5x tangent 5x? I can write in the form like sequence to 7 5x and then sequence 5x and then tangent 5x. You see that? And basically you see sequence 5x and tangent 5x in here, right? And that is in du. You see, when you do this substitution, you see that? And the second part, the remaining part, means sequence, that is just u, right? So it seems like if you use this substitution, you can get the answer right away. Okay, let me show you this. And then we'll do in the second way, okay? And we compare which way is better. And then finally, we will do some conclusion, how to do substitution when you see sequence and tangent. If I put u equal to sequence 5x, so I have that. From here, based on this expression, right, I can rewrite my original integral. This guy is just equal to, so I have sequence to 7th, that is u, okay? And we have sequence 5x tangent 5x in here together with dx, right? Together with dx. So if you get together with dx in here, that is just du over 5. You know, you divide both sides of this by 5, you get du over 5. So I have u to 7 du over 5. So that's 1/5. And I use the power rule for this. I have u to 7 plus 1 over 7 plus 1 plus c. So that is, you know, 1/5 with 1/8, so 1 over 40. And then u to 8 plus c. And then I have to plug, you know, the substitution into this formula, I get 140, and then sequence 5x to 8 plus c. The solution is pretty easy. All right, so if you do u equal to tangent of 5x, you have du equal to secant square, right? So, but in the original integral, you have the following one. You have secant to 8, 5x. Here I should write, I just forgot about 5, right? So I have to write 5 in here. Okay, and then I have 5 in here regarding the chain rule. Okay, so I have secant to 8, 5x. So what is that? I have to split this into secant square, right? Secant to 6, 5x times secant square 5x, because I need secant square 5x for my du in here, you see, this is for my du right here. So that's why I need to split this into secant to 6 times secant to 2, right? So and then I can rewrite my original integral, but I have to handle secant 6. What is secant 6? Secant to 6 means secant square 5x cubed, right? Secant square 5x. The reason I rewrite in this form because we want to use relation between secant and tangent. Where's that? That is secant square equal to tangent square plus 1. You see that? So if I rewrite in this form, so my function looks like tangent square 5x plus 1 and then cube, right? And then secant square 5 of x. All right, now I'm ready to rewrite my original integral in terms of u. So my original integral is here. I just denote that by I, okay? So let's use another ink. I equal to integral of tangent square 5x plus 1 cube, right? Just do that, and then in the next we will rewrite in terms of u. So I have secant square 5x dx. Since we put u equal to tangent 5x, sorry, we still have tangent over there, right? We still have tangent of 5x dx over there. So we put u equal to tangent. From here I have du equal to secant square 5x and then dx times 5 in here. 5 is the derivative of 5x. So I is equal to u square, right, plus 1 cube times secant square 5x dx. Secant square 5x dx. No, that is just the okay, tangent 5x is u and then times du, and we need to divide by 5, so I get 1/5 in here. We need to divide by 5 because of this, right? Because secant square 5x dx is du of 5. This integral is solvable. Of course, you can, for this out, and then you evaluate each term using the power rule. But if we compare this approach with the previous one, so the previous one is easier and faster. All right, so here is the experience from this example. So if you see something like that, right, with sequence to 8 or sequence to an even power and then tangent, so probably you put u equal to sequence. Okay, so I hope that this video is useful for you, and look forward to seeing you in new video. Bye bye.